Let's look at OpenStack's College Physics Chapter 15, Problem 14. Calculate the net work output of a heat engine following path ABCDA in the figure below. So all of the information that I need is in the graph, and so let's look at the graph first. So we want the work done from A, B, C, D, A, the work done in this one cycle. And remember that the work done is area under the curve. So for process AB, the area under the curve would be this whole thing. Then from B to C, this is an isochoric process. The volume is constant along it. So the work under the curve here is nothing. There is no work done. There is no curve to find an area under. So the work for an isochoric process is 0. Same thing with dA here. There is no work done along that process. But for process CD, so that goes in this direction, I know that the work is the area under the curve. And the other thing I know for that is that the work in that area is negative. For the previous process that had non-zero work, the process AB, I know that the work was positive. How do I know it's positive? Well, work is, generally speaking, P delta V. So I take a value of a pressure and then look at the delta V. And delta V in this situation is VB minus VA, so that's 4 minus 1, and that's a positive number. When I look at process CD, then the area under the curve will be pressure times volume at D minus volume at C. And that is 1 minus 4, so that's why it gives me a negative number. Now, the example that I gave you with P delta V is true for an isobaric process. This is not an isobaric process. The pressures are different. The pressures are different here as well. So I can't just use P delta V. What I have to use is the area under the curve. And so that means that I just need the area ABCD. So how to do this? Well, I can break this up into two triangles. I have ABD and BDC. And I know the area of a triangle is base times height divided by 2. So I would have base times height divided by 2. And I have all of those values. So I'm not going to write down any knowns and unknowns. I guess I can write for unknown work A, B, C, D, A. That's what I'm looking for. But the knowns are in the diagram already, so I won't write those down. All right, so work A, B, C, D, A is work A, B, D, A plus work B, C, D, B. So the area of ABDA, this area, is going to be base. So base is 2.6 times 10 to the 6th minus 1.0 times 10 to the 6th times height, and that is 4.0 times 10 to the negative 3rd minus 1.0 times 10 to the negative 3rd divided by 2. And to that I have to add the area of the second triangle. So the base of that is 2.0 times 10 to the 6th minus 0.6 times 10 to the 6th. So that's the base. The height is the same as the previous height, 4.0 times 10 to the negative 3rd minus 1.0 times 10 to the negative 3rd divided by 2. So we end up with 4.5 times 10 to the 6th joules when we do all the calculations.